Okay, so we have sine squared theta minus tangent squared theta over cosine squared theta minus cotangent squared theta. Over cotangent theta. Now, just because of space, I'm only going to say the reason. We're not going to write the reason, and I might take two steps at once if I have to, because I'll never be able to do this space-wise. But let's see what we can come up with. So, you ready? You ready, Savon? Is that a no? Savon, you want to do it? You don't have to. I know this is all kind of new. You right? Okay, let's try. So what are we going to do first? Yeah, I would. So let me write that down. So we have sine squared theta minus sine over cosine over cosine squared theta minus cosine over sine. Okay? All good? All right. So now, let's see. You ready, Savon? What's next? Use your algebra. Most of this is algebra. Good. I'm going to get a common denominator. Let's get a common denominator in the numerator separate from a common denominator in the denominator. Okay? Okay, so what can I write? Do you have a microphone, Savon? Are you on a laptop? If you're on a laptop, just hit that talk button. See if it works. Oh, I see. Let's try. Let's see if it's okay.
So.
Yeah, it's fine. We don't hear the background.
Pardon?
I don't hear the background.
Okay. So for the common denominator, we do it as cosine squared minus cos over sine. And we multiply.
Say it one more time.
Would we multiply the entire equation by sine squared minus cosine over sine?
No, let's just take the numerator separately from the denominator. So this being the numerator, this being the denominator.
Okay, so for the numerator, we multiply it by cosine theta, and then the denominator we multiply.
Wait, one in there at a time. So I'm going to So let's do it like this. I'm going to multiply the first term by cosine over cosine.
Yep.
And then since I have a common denominator, I'm just going to say minus sine theta. Is that fair?
Yeah.
Does everybody see what I'm doing? Is anybody lost? Okay. And then I'm going to put that. You're lost, Kirkland? Okay. You're lost, Kieran. What are you lost about? All I did is multiply. I multiplied the first term here by cosine over cosine, and then I combine I combine them into one fraction. Kirtan, are you okay? You see what I did?
So then
Okay. And then what am I going to do in the denominator?
Well, for the numerator, can we just cancel out the cosines, or not yet?
Say it one more time.
Can we cancel out the cosines in the numerator, or will we do that?
Well, if we cancel out can we cancel out the cosines?
In the numerator, couldn't we?
No, because you can't cancel terms. You can only cancel factors.
Got it. So in the denominator, it would be cosine squared theta times sine theta.
Right.
Over, oh wait, no, it would be minus cosine over sine theta.
Good. Does everybody see how I get this? All I did is multiply this. No, yeah, that by sine over sine, right? Okay, good. Okay, Siobhan, now what?
So, I mean, you already said that we can't cancel out terms, so we can cancel the cosines out of the sines.
So I cannot cancel
Right.
terms. I can only cancel factors.
Exactly. That's why right now. Yeah.
So now I just do whatever I would do when I divide fractions. I would keep the first one the same.
Oh, right. Yeah, you do keep change flip, right?
Right. Keep change flip. Times the reciprocal of the denominator I'm sorry about my handwriting, I really am. It's just this thing is kind of a little bit hard to write on. Okay. And then is there anything I can do now?
Oh, now you can cancel out the cos theta sine squared theta minus sine theta.
What am I going to cancel that with?
Yeah, exactly. I thought you said that. I saw the cosine theta sine squared theta, and I was about
I understand. So the best thing to do whenever you get into a position where you don't know what to do, since I can cancel factors and I can't cancel terms, probably the best thing I should do is what?
multiply.
Factor. Because I want to see if there's anything I can cancel. Right?
Right.
Okay, so can I factor anything? Smader, can I factor anything here? Cosine where? Where am I going to factor cosine from? I can't hear you. If you're talking, I can't hear you. Can you turn your volume up on your microphone if you're talking? Stacy, do you see anything we can factor? Stephen, can we factor anything? So let me just put it this way. The answer is yes, but now you have to tell me what. Hold on, Michael. From where, Smader? Where am I going to factor sine from? The numerator, good. So I have sine theta, and then I have cosine theta, cosine theta, sine theta, minus 1, right? And can I factor anything else? I can factor cosine theta, and what do I have left? I have cosine theta, sine theta, minus 1. Okay. Okay, Siobhan, can I cancel anything?
Now we can cancel out the cosine theta, sine theta, minus 1.
Yes, exactly. Because those are factors now.
So then it'll be sine squared theta over cosine theta, so then it'll be tan theta, tan squared theta.
Right. There we have it. Good? See why your algebra's got to be really good? This is where your algebra's got to be really good. Because we're using algebra in a completely different way now. Okay, any questions? I'm not going to do that one. Oh, I can do this one. Okay, so yeah, I will when I get to one. We'll have some problems. I just don't have. Let me see if we can come back. I guess. Let's see. Here, this is one. Okay, so do I have any volunteers from the bottom part of my screen here? Either Smader, Stacy, Stephen, Tim, or Tuyette. You got it? Okay, let's do it, Smader. So how do I start here? Okay, and what do I get when I eliminate the parentheses? You can use your microphone if you want, if you don't want to type all this in. Yeah, I can't hear you. I think it's your, just check the volume on your microphone. And like up at the top above the talk, there's a little slider. Make sure that's up too. Can anybody hear him? Yeah, I can't hear you. I think your microphone's working, it's just I can't hear what you're saying. It's something about the volume, I believe. I'll come back to you, Smader, when we don't need a microphone. This would be somebody who has a microphone would be good for this one because there's a lot of, I'm going to write a lot, so it's probably best if someone could just tell me what to do. Does anybody have a microphone who wants to volunteer? Lauren, you want to volunteer?
I'd like to.
Okay, good. Let's try.
All right, like Smader said, we should eliminate the parentheses, so I guess that would mean on the left side that sine x minus cosine x squared would equal sine squared x minus cosine squared x?
No.
Oh.
How do you, so you guys have to stop this.
Oh, I forgot that.
Yes, you need to FOIL. You need to multiply. It's really important. You're going to keep making this mistake. It's going to be bad. Like, y'all are going into calculus. Most of you are going into calculus next. So you've got to get your algebra really solid. Yeah, well, you can combine like terms. So it becomes sine squared x minus 2 sine x cosine x plus cosine squared x. I don't think anybody actually gave me that. Even you, Kerton, look and see. You don't have it yet. So really important. Okay, Smader, let's go back to you. Is there anything you see that I can do here, Smader? The microphone doesn't work. Okay, yeah, you're not going to be able to use your mic. So what's the next step? Replace sine square with what? That's true, you can. There's a little bit better, easier, quicker way to go. Does anybody see it? But you're not incorrect, Smader. That is a correct answer. Just there's a better one. Does anybody see it? No. Yes, exactly. I have sine squared plus cosine squared, and I can just make that 1. Okay? So your answer, Smader, was not incorrect. It would have gotten you there. Where did you say that, Griffin? You wrote 1 minus, oh, I see, you did, sorry. My bad. Thank you, good job. And then, so this is, we use the Pythagorean, right? And then I want to make it look like this. So remember, with odd even, so this is the odd even question. With odd even, I can say that f of minus x is equal to minus f of x, right? So I can say this is 1 plus 2 times the sine of minus x cosine x. And that's because of odd and even. Because the sine of minus x is equal to minus sine of x. You see that, Michael? Michael T. Okay, so this would be, the reason I can go from here to here is because of odd even. Does everybody see this? Is there any questions about this? Let's see what else I can find here. Oh, this is very important. So show that this is not equivalent. This is important in a lot of ways. So you want to show that this is not. How do I show something is not an identity? Who can tell me how to show something is not an identity? Good. I just find, if I can find one contradiction, identities are always true. If I can find one time that it's not true, I've proven that it's not an identity, right? So let's just pick any number. Pretty much anything here is going to prove it's not. So let's say x equals pi over 4. Okay? So I have the sine of 2 times pi over 4. That equals the sine of pi over 2. What's the sine of pi over 2? Sine of pi over 2. 1. So now let's say 2 times the sine of pi over 4. That's equal to 2. And there you go, Anka, times the square root of 2 over 2, which is the square root of 2. These are not equal, so it's not an identity. That's it. Okay? So there's a lot of reasons for this slide. First of all, the most important reason is the sine of 2 times x is not equal to the 2 times the sine of x. That is not interchangeable. The cosine of alpha plus beta is not equal to the cosine of alpha plus the cosine of beta. And we can come up with a counterexample, but it's very important that you don't do this. It's not true. Okay?